You almost look like you're smiling a bit. Are you?
Oh, no, I might.
Heath implanted electrodes in the brains of chronically depressed patients, hoping to stimulate pleasurable sensations.
I guess I've cracked up all the way. I don't know.
I mean, that's the reason you're smiling.
Probably.
Or you look like you're really... What are you laughing about?
I don't know.
Huh?
What do you mean? Are you doing something to me?
Not surprisingly, the experiments were controversial, but the electrodes did have an effect, especially near an area of the brain called the nucleus accumbens. Heath even let his patients control their own stimulation.
I find this button the best.
That's number 2 button.
Most pleasurable.
Mm-hmm. How do you feel?
I made a small joke yesterday. I don't know if I should repeat it or not.
I'd like to hear it.
Do you think it's worth repeating? What about the very deep, deep electrode all the way down?
You're trying to tell me how it excites you, is that it?
Oh, I think it's somewhat of a sexy button.
Yeah. Is that why you said it went all the way down?
Perhaps we get pleasure from drugs because they stimulate the same brain areas as sex and food. Working in Montreal in the 1950s, James Olds devised a crucial test. He worked out a new way to, in effect, ask animals how they felt.
This is a device which trains the animal to turn on the stimulus for himself. Here you notice the animal wandering toward the pedal. When he first touches it, he gets no stimulation. It's not connected yet. Then, one time he touches the pedal, it does turn on the stimulation. You can see the lights go on.
Now, the interesting thing about the old stimulation, the rewarding stimulation, was the strength of it. It was somewhat different than rewarding stimulation for food and water in that there was no satiation. Animals would continue for hours and hours and didn't seem to satiate. They didn't feel full. They would just keep doing it for long, long periods of time. They would do it to exhaustion.
Now, I will electrify the grid. The animal must cross an area that gives a very painful shock to the feet in order to get to the pedal and stimulate the brain.
And a rat wanting brain stimulation would brave a shock stronger than even a starving rat would brave to get food.
This shows a rat is willing to pay a very high price in order to get to the pedal.
Human addicts will pay just as high a price for their rewards.
The fascinating thing was that we found in our laboratory that every single drug that increased sensitivity of the animal to brain stimulation was either an abuse substance or a substance that has potential for abuse.
So James Olds' technique of the 50s gave scientists a way of testing for the addictive potential of drugs. And a way to find out where in the brain they acted.
Now, I think there's general agreement that this is the area where the action is in terms of the rewarding effects of drugs. Whether they be heroin, whether they be amphetamine, whether they be cocaine or angel dust or whatever, any drug that produces rewarding effects, it's believed this is where the action is.
Using similar methods, Chris Fibiger and his colleagues in Vancouver wanted to know which pleasure areas are active when we crave both drugs and food. They found that the area Heath stimulated in his patients, the nucleus accumbens, is the center of a key network, the dopamine circuit. Heroin seems to act in one way. Cocaine in another. And both hit the nucleus accumbens, which the Canadian scientists recently proved is also active when we crave food.
If we selectively take these dopamine neurons out of that part of the brain, the animal loses interest in self-administering cocaine, it seems. apparently the drug is no longer reinforcing. The same story seems to apply for amphetamine. If you destroy these dopamine-containing neurons in the nucleus accumbens, amphetamine self-administration disappears as well.
A heroin addict has volunteered to be given a large dose of morphine, chemically similar to heroin, by scientists at the National Institute for Drug Abuse in Baltimore.
Relax.
Today, using new methods, researchers can at last start to look at where drugs act in the human brain. The new machines reveal why different drugs make us act like primitive animals. Morphine shuts down the higher cortex and leaves the older emotional brain in charge. Cocaine gives a boost to the whole brain, but especially stimulates the primitive centers of emotion. So from those rough and ready experiments in the 1950s, scientists did learn where in the brain many addictive drugs act.